Yeah, okay, now I am recording. Okay, so you asked some question about some diagram. Which diagram? This one?
16 and 16.
16-16.
16-16.
Here.
Yeah, so here the, so to speak, logic constraints are used. Yeah, so start to start, start to finish to start, finish to finish, and then the time that is used for the whole.
Yes, yes. Actually, last time I have not yet reached, so I was actually going to
Today.
discuss the same. Yes.
Okay. Okay.
Yeah.
Good.
So as I remember, I finished here last time. Okay. So here I just introduced the lags. So this is the finish to start relationship, but with the lag of say 2. Okay. And this was the start to start relationship with some lag or without lag. Okay. And this is the finish to finish relationship. Okay. So now if we consider this situation where we have an activity clear and grub, okay, and clear and grub, and then there is another activity cut and fill, okay. So cut and fill finish activity can only be started when clear and grub activity can be finished. But in as a but as a for example, as an option, we don't have to, sometime we don't have to finish the finish of the previous activity to start the next activity. So in that case, if cut and fill activity can be started just when the clear and grub activity has been finished almost like 50%. So if clear and grub activity takes 2 weeks, and 1 week has passed, maybe we can start the cut and fill activity as well. So in that case, if we want to represent it in the activity on arrow diagram, okay, just like in this A case over here, just if we want to present it in the activity on arrow diagram, then what we can see is we have to divide this clear and grub activity into 2 sub activities. So clear and grub 1 and clear and grub 2. So both are representing the 1 day of 1 week of work. So in that situation, one clear and grub activity, clear and grub 1 activity is completed, then we can logically connect it with the another arrow, which is represented by cut and fill activity. So this is one of the ways in which we can represent this type of situation in the activity on arrow diagram. If we want to represent it on the activity on node diagram, we normally will not have to divide this clear and grub activity into 2 sub activities. So we can just use clear and grub activity as it is. And instead of dividing this activity into 2 activities, we can represent a start to start relationship. We can put a start to start relationship. So here we can put like S is equal to 50%. So which will mean that when this clear and grub activity, which is the preceding activity, has started for 50%, that means 50% of the work has been completed. The next activity, cut and fill, can be started. Okay, so this will we can represent it in this way. So in this case, there may be in the activity on arrow, activity on node diagram, there is some slight advantage to that activity. Okay, so this is the difference between the activity on arrow and activity on node. So when we want to represent some lags. Next diagram, if you move to this next diagram, this is the same diagram which we represented before for activity on arrow method. So you can see that if you remember, for activity on arrow, yeah, we did these calculations. Okay. So if we want to represent this diagram in the activity on node, so then we can represent it like this. Okay, activity on node. So this is a activity on node type of diagram. And it is also a precedence diagram. Although in this precedence diagram, normally we specifically use precedence diagram for those diagrams in which we use the lag relationship, such as there is a lag between the finish to start, or there is a start to start relationship, or there is a finish to finish relationships. Although in this case, because we are just simply representing it, the previous example, in which there were only finish to start relationships. So therefore, there are no finish to finish and start to start relationship. There are no lag relationships over there. So it is a precedence diagram, and of course, precedence diagram is, in simple words, it's actually an activity on node diagram. So, however, in this precedence diagram, you can see that the calculations we can also verify. So it is the same diagram. That means once we have the activity precedence relationships, you can either create the activity on arrow diagram, or you can create the activity on node diagram. It is your choice. But in the current times, now activity on arrow diagrams have been replaced almost everywhere by the activity on node diagrams or the precedence diagrams. So therefore, most likely in all the practical situations, we will be using the activity on node and precedence diagrams. So the calculations are quite easy in this case. So for example, although these have been given over here, so you can see from here is that if I want to represent these diagrams of these calculations over here, so we will start from this 0, okay, and 0 plus 1 will be 1. Sorry, we will start from 0. Oh, actually, this is not an activity. This is actually a, you can see that this activity, the duration is zeros, which means that this is not an activity. This is a starting milestone. So this is a start milestone. Okay, so milestone is an activity with a 0 duration. So this just shows that we are starting from here. So since we are starting from here, at the start, we have now 4 activities. Okay, so in the case of the activity on arrow, we were representing it like this, right, with 4 arrows. But here we are representing it with 4 nodes. So all nodes are starting from 0. Okay, all nodes are starting from 0. So this is the early start time. So from the early start time, add the duration, then we will get the early finish time. So 0 plus 4 is 4. So 0 plus 4, we can get this. Okay, so 0 plus 3 is 3. Okay, so we get this. 0 plus 5, we get this. And then similarly, 0 plus 2, we get this. Okay. So from here, we have already get from the early start time, we have got the early finish time. Okay, can you hear me well?
Yes, we can hear you.
Yes.
Okay, okay. So once we have drawn this network over here, so then we can perform these calculations. So this so now in this case, this pump house is starting. Pump house is starting when drill well is finishing. So if drill well finishes at 4, so we can start the pump house at 4. So this 4 goes here. So, and so from here, like this, so from here, there is the arrow from going towards here. Okay. So this 3 should be going here, but this 7 should also be coming here. So therefore, now we have 3 and 7. Okay, so out of 3 and 7, we will take 7, the higher value. So 3 we will not take. So this 7 will go here. Okay. Similarly, from here, 5 is coming over here. So 5 is coming from where? So this and this has no relationship. So for example, this 5 is coming from here. So here. And yeah, this 5 is coming from here. There is only one arrow going into that. Okay, so this 5 is coming from here. Okay, and then 2 is coming from here. Okay, so now once we get these values, so this 4 plus 3 is 7. Okay, so 4 plus 3 is 7. Yeah, 7 will come from here. And 7 plus 2 is 9. Okay, and then 5 plus 6 is 11. Okay, so we will get it. So 5 plus 6. And then this 5 plus 4 is 9. Okay, and then 2 plus 4 is 6. Okay, so we already got these values. So from here, now we have 11. So from here, 11 will come over here. And from here, 9 will come. And then from here, 15 will come. But that 15 will have to be calculated from here. So from here, 6. And from here, it will be 9. So from out of 9 and 6, we will take 9. Okay, 9 will go. 6 will not be taken. Higher value will take. So 9 plus 6 is 15. And then this 15 will go here. So out of 9, 11, and 15, you will take 15. Okay, so 15 plus 0, that is 15. That is, of course, this is this is not an activity. This is a finish milestone. So although representing the start and finish milestone is not necessary, but it always is advantageous because it creates the what do you say is the clarity in the picture. Okay, so this is how the calculations are going in this way. Okay,
Professor, I have a question.
Yes.
What do you mean by clarity? So why do we need these numbers?
The clarity is about which numbers you mean?
For example, 15, 15, 15, and 15 at the end.
Oh, yes. So I have said that it is not necessary to provide these numbers because these are the milestones with 0 activities. But it makes it more clear that where the project is starting and where the project is finishing. Because if we, for example, if we did not provide over here, then all these 4 activities are starting simultaneously. But in this case, it is better that to represent their common start. Okay, so this provides a common start. Okay, and similarly, these 3 activities, 10, 7, and 11, okay, are have no successor activities. Okay, so therefore, this a successor milestone over here provides a common finish. Okay, common finish. So therefore, it makes the network more clear. Okay, to provide it. Okay, so it is always better when so therefore it is always better when 2 or more activities are starting, then provide a start milestone, or when there is 2 or more activities are at the end, then you should provide a finish milestone. So it is always better. If, for example, if the project is only starting with 1 activity, then there is no need to provide a start milestone. Then that activity will serve as the start milestone. Okay, and similarly for the finish milestone. Okay, good. So in this way, we have performed the forward pass calculations. So since I have put so much stuff over here, so maybe I can remove it so that we can perform the backward pass calculations.
May I ask, Professor?
Yes.
So these values which are given at the beginning of diagram, drill well, power line, excavate, deliver material, all these numbers were taken from the previous diagram. Yes?
Yes. Which
Okay.
for example, initially, of course, initially we will have only these numbers. Okay. Let me see. Let me answer you. Initially, we will have the drawing is. Oh, sorry. What's I have clicked something. Ah, okay. What I understand from your question is that you're asking that what numbers initially we will have. Initially, we will have only this duration number. Okay. So this one, this, we will calculate it. Okay. So we will have the activity precedence relationships and the duration of the activities. And from there, we will calculate these numbers. Okay.
Okay, thank you.
Okay, so now for the similarly for the backward pass, we will go from this 15, 15. Okay, so 15, this 15 will go here. Okay, and then 15 minus 6 will be 9. Okay, 15 minus 6 will be 9. So this 9 will go here. Okay, and 9 minus 4 will be 5. And then this 9 will go here. Okay, and 9 minus 4 will be 5. Okay, and then similarly, from this 15 will go here. 15 minus 6 will be 9. Okay, and then this 15 will also go here. 15 minus 2 is 13. Okay, and then this 13 minus 13 will go here. Okay, 13 will go here. Yeah, and right, so there is only one. And then this 9 goes here, but we have 9 from here and 5 also goes here. So out of 9 and 5, and out of from here 13. Okay, so we will get 13, 9 or 5, we will get the lowest value 5. Okay, so 13 goes here, 13 minus 3 is 10, 10 goes here, and 10 minus 4 is 6. Okay, and then from here 5 goes here, 5 minus 2 is 3. Okay, so out of now we will get 13 minus 3 is 10, 10 minus 6, 4 is 6, 5 minus 0 is 0. So from here, one value will be 6, another value will be 10, another value will be 0, another value will be 3. So we will take the lowest value, which will go here. Okay. So in this way, the backward pass calculations will be done. Okay. And after doing the backward pass calculation, so then you can calculate the float. So float is given over here, TF. So float is equal to the LS minus ES or LF minus TF. So float for this will be 15 minus 9 is 6. So 15 minus 9 is 6, or in another word, 13 minus 7 is also 6. 13 minus 7 is 6. 10 minus 4 is 6. 10 minus 4 is 6. 6 minus 0 is 6. 13 minus 13 is 13 minus 3 is 10. Okay. 15 minus 11 is 4. Okay. 9 minus 6 is 9 minus 9 is 0. 5 minus 5 is 0. There here from here 15 minus 15 is 0. 9 minus 6 is 3. 5 minus 2 is 3. So the total float will be calculated in this. So is it clear, the calculations?
Yes.
Professor, I have a question. Can you clarify how did we get 10 in power line? So 10, it means instead of ls.
This one, let's
Yeah,
start.
yeah.
So 13 minus 3 is 10.
So we create these like numbers like 10, 3, 13 after we did the whole scheme, like after we did the whole plan.
Yes. So first we will create these first we will calculate these two numbers. Then we will calculate in the forward pass for all activities. Then we will calculate these numbers, okay, the late numbers in the backward pass calculations. So this 13, for example, for this 13 will come from where? This 13 will come from, because there is one activity over here, right? And yeah, there is only one activity over here. 13 minus, so this 13 will come from here, okay? This 13 will come from here, okay? Because this power line finishes, then install pump starts.
But how we decided the number like 3?
The duration?
Yeah, duration.
Oh, okay. So how do we decide, for example, where is this? The duration of each activity have to be calculated before, okay? Before performing the calculation.
Okay.
Using some estimating techniques, using some expert judgment, using some past data. So this is, of course, this is an input data for the project schedule.
But Professor, I think duration should have some like unit.
Yes. Yeah, days, weeks, hours, minutes, depending on the size of the project.
Yeah, but what does mean like 3, 4, 5? How we can relate them to minutes time like?
Here we are taking a week. Okay, so the time unit is week.
Okay, I get. Yes, thank you.
Sorry. Sorry if I have said days sometime, because I am more used to saying of the days. Okay, so everywhere is week. So if once you set the units, you should keep the same unit. Okay, week.
Okay.
So if I have said sometime days, then I think it is just by mistake. Okay, it's week. For this project, I am using duration as the week. So we estimate that the drilling of the well will take 4 weeks to complete. Power line installation will take 3 weeks to complete, something like this. Or we can even say days as well, but that doesn't matter. We are because we are just focusing on the network calculations. So here, I think by doing this calculation, now we have covered the AON forward pass and backward pass calculations. Okay, so so first so in the AON forward pass and backward pass calculations, first you will calculate the early start time and early finish time. Okay, and then we calculate the that is in the backward pass. So and then in the back that is in the forward pass, and in the backward pass we will calculate the late finish and then late start time. Okay, and then in the end we calculate the total float for each activity. Okay, so this is how the calculations are performed. So remember that this is these are the same, these numbers will be the same which we will get from the activity on arrow network diagram. So activity on arrow network diagram, we perform these calculations in slightly different way or format, but the end results for each activity, there will be the same early start, early finish, late start, late finish, and total float times. Okay. Okay, now since we are talking about the precedence diagram, and the precedence diagrams are specially for the introducing the lags. Okay, so if we introduce the lags, then we can draw the same diagram, but with some modification. So if you see that the diagram which I am showing is that it is it is the revised example, revised. What is the revision which has been made? The revision is that we have introduced 3 changes. Okay, we have introduced. So first change is this one. Here we have the in the install pipe and the install pump, there was no finish to finish relationship. So if I go back to the previous diagram, so you can see that there was no relationship between the install pump and the install pipe. As you can see that no line is connecting the install pipe to the install pump directly. You can see that, right? Is it correct?
Yes.
Yes. So there is no line. But now we have introduced a relationship that the install pump cannot finish earlier than the install pipe. Okay, cannot finish. So here we can see that in our previous calculation, here we can see that install pump was finishing at 9 weeks. Install pipe was finishing at 11 weeks. So here you can see that if you just imagine the type of work, if you just imagine the type of the work, you will maybe it is not a good idea to finish the piping, to finish the pumping installation before the installation of the pipe. I don't know what is the nature of the work, but maybe one can say that installation of the pump is will only be good before the installation of the pipe. Okay, so therefore there should be a finish to finish relationship between the install pump and the install pipe, so that installation of the pump will not finish before the installation of the pipe. So this is what has been done over here. Okay, so there is a finish to finish relationship that has been introduced over here. So this finish to finish relationship, and then in this finish to finish relationship, you can see that we have joined it with this arrow. Okay, so this arrow is starting from the finish of this finishing phase of this box to the finishing phase of this box. Okay, so you can see that if we are representing these activities with these boxes, so this is the start and this is the finish. Okay, so here we can here the arrow is starting from the finish to the finish, and here if you can see that that finishing relationship has been introduced, finish to finish relationship has been introduced with the lag of 1 day. So it means that if install pipe finishes at 11, then install pump will not finish earlier than 12. If install pipe finishes at 15, the install pump will not finish earlier than 16. So there is a lag relationship between finish to finish. Okay, so this was the first change. And the second change was this. The second change was this, that the tower and tank will not start at least 3 days after the finish of the foundation. So maybe due to the site constraints, this may be the requirement. So once the foundation is completed, there is a waiting time of 3 days. Only then the tower and tank can be started. So this relationship was not there before. Okay, let me go back to the original figure. So this relationship was there. Yes, this relationship was there, but there was no lag. So that means once the foundation was started, the next day the tower and tank can be started. But now we have introduced a 3 days of lag over here. Okay. So in this case, in the changed relationship, if the foundation is finishing at 7 days, if the foundation is finishing at say this 7 days, okay, then the tower and tank will be starting at 10 days, 3 days of lag. So so this shows a finish to start relationship. So you can see that this is the finishing phase of this box, and this is the starting phase or edge of this box. So finish to start relationship with that 3 days of lag. Okay, lag of 3 days. Okay, So 7, and then it will be 10 over here due to this lag relationship. Okay, so this was the second change. The third change over here is to introduce this start to start relationship. It is found that we don't have to wait for the excavation to finish, okay, to start the foundation. Okay, so the project manager or the construction manager over there has said that we don't have to wait finishing the excavation completely. Maybe when the excavation has been done for like 3 weeks, we can start the foundation work. So therefore, there is a start to start relationship has been added. So you can see that this relationship is starting from the starting phase to the starting phase of the foundation, okay, and which is represented by 3 days. So originally, this relationship was not there. Instead, there was a finish to start relationship. Here you can see that you have this excavate and then foundation. So this foundation was connected with the excavate with the finish to start relationship. But now that finish to start relationship has been removed, and it has been replaced with the start to start relationship. So this start to start relationship then ensures that we can start the foundation earlier. So you can see that now the foundation is starting at 3 weeks, but earlier it was starting at what? Earlier it was starting at 5 weeks. So now we can start the foundation a little bit earlier. That is 2 weeks earlier. Okay. So here these are the 3 changes, and according to these 3 changes, now the calculations have been performed. Okay. So remember that when performing the calculations, you must follow the lines of the relationships. Okay. So this will mean that now, if for example, if we want to go from excavate to foundation, so if for example, if we will calculate this to be 5 over here, now we will not take 5 over here, because that will mean that we are following the finish to start relationship, but there is no finish to start relationship here. There is a start to start relationship over here. So this, which will mean that if this is 0 and 0 plus 3, that will be the start over here. Okay, so it will. So this 3 will follow the start to start relationship, not the finish to start relationship, because there is no finish to start relationship here. Okay, so this is the only difference between these 2 calculations. And then if you will perform the same if you go by the same approach, forward and backward, you can get the same numbers for the activity start and finish times.
Excuse me, sorry, could I ask a question?
Yes.
Why the start of the install pump is early start of the install pump is 10?
Here, yeah, early start of the install
Early
pump
start
is
is
10.
Yeah, why?
10. Yes. So okay. So let's see, because this install pump, the start of this install pump is depending on this pump house. So from here the value is okay. So one of the value will be 7, which will be here. Okay. So one of the value will be 7, and the another value which will come from here, which will come from here.
3 and 5.
3, and it will come from here. It will be 5.
Right.
So it should be the higher of the 3 values, 7, 3, and 5, but it has been shown as 10.
Yes, that's why I'm confused.
I am also confused. So let me think about it. Why?
Because of the lack of the install pipe of the 7th action. So it should be, there is a lack,
Okay.
finish to finish. So 11 plus 1 is 12. So we cannot start until the 10th week.
Yes. Okay. I got, yes, I got your point. So, okay. So 7, 3, and 5 is fine. There is no problem with that. But instead of, before deciding about this, we have to take care of this finish as well. Okay, so for this finish, what are the options over here? So for this finish, we have 11 plus 1 is 12. Okay, and yeah, correct. Now, remember that when we are performing this forward pass calculations, we have to, there is a small tip over here, is that this we have to take care of these arrows as well. So there are 3 arrows actually over here. In fact, there should be 4 arrows because of this confusing joining of these relationships. It is showing as 2 arrows. Anyway, one value is 7, 3, and 5. So for this, we should take 7 over here, and then 7 plus 2, 9. But we cannot take 9 over here because from here, now we will get what happened? So out of 9. So one value will be 12, another value will be 9. So we have to take this higher value because otherwise it will finish at 9, which is not possible. So therefore, highest of the 3 values, highest value will be taken. So from here we will take 12, and then 12 minus 2, then we will take 9.
So we need to consider it. Okay, thank you.
Yes, so we have to, yes, so when we are performing the forward pass calculation, we have to be careful about the arrows. So how many arrows are going into that activity? Okay, so that's why. All right, any other question? Okay. So that was the precedence diagram. Okay, so so in this way, then we can perform the forward pass and backward pass calculations. So remember that in these forward pass and the backward pass calculations, we have assumed that these calculations are on the assumptions that all the resources are available to perform those activities. But sometimes the resources are not available to perform those activities. And then those resource constraints can affect the activity times as well. So now let's look at the resource assignments. That means scheduling and resource assignment using the critical path method. So in this case, we can have the 3 types of schedules: early start schedule, late start schedule, and the other schedule, which is somewhere between the early and the late start. And then we need to consider the resource assignments. So let me show you what do I mean by this. Okay, so first look at this bar chart. Okay, look at this bar chart. So this is the allowable activity time span for the example network. Okay. You see that this is the bar chart which we can draw from this schedule. Okay, from this schedule we can draw this bar chart. So for example, how we can draw this bar chart? So you can take the early start and late finish time of each activity. Okay. So for example, if you take this activity drill well, so we can take the 0 and 10 for this activity. 0 and 10, because this is the earliest an activity can start. This is the latest and this activity can finish. Okay. And similarly for the pump house, we can take 4 and 13. Okay. So if we take this information and then put it into this bar chart, so for example, this and then this, and then after drill well, and then for each of the activity, we can input that information into this chart. So we can get a bar chart. Okay. So this bar chart shows the allowable activity time span for each activity. Okay. That means although this drill well takes the duration for the drill well is 4 weeks. Okay, D can be also set for the days, but here the meaning of the D is duration. Okay. If drill well takes 4 weeks, we can represent it in the form of this line over here, starting from 0 to 10, because it can start early as early as 0, and it can start as late as 10. Okay, but anywhere between this we can schedule this activity. Similarly, deliver material from 0 to 5, although it takes only 2 weeks to complete. Excavate 5x to complete, because this is the critical activity. Excavate is the critical activity. For this, the total float was 0. So this we have represented it in a different way with the thick line. And similarly, all the other activities have been represented between their early finish time. Okay. Therefore, we have represented the activities between their early finish and late start times. Okay. So remember that if there is early finish, then there will be early start as well. And there is late start, then there, late finish. Sorry. Okay, let me say it again. I said it wrongly. Okay. We have represented all these activities. We have represented all these activities between their early start and late finish. Okay. If we have the early start, then we can calculate the early finish by just adding the duration. If we have the late finish, then we can calculate the late start by adding by subtracting the duration. Okay. So anyway, but we have just represented these activities, all the activities in the project, by the early start and the late finish dates. Okay. So that we can say that we have this much of the freedom in those activities. Okay. Early start and early finish. Early start and late finish. So what I was saying is that, so in this way we have represented this network. So this is the network. So we can use this type of bar chart for scheduling purposes. So once we have drawn this network, okay, now we can represent the it with the early start schedule. That means we assume that all the activities are starting at their earliest start time. Okay, and then we can represent that information into the network. So here in this figure, it has been represented. So remember that we have represented this drill well activities between its early start and late finish time, but it has only it has a work of only 4 weeks. So if we start the work on this activity at the earliest, so it will take only 4 weeks to complete. So these have been represented over here with the asterisks, and the remaining work and the remaining part of this activity has been represented with the letter F, because it has a float available. Okay, over here. So similarly, for the deliver material, 2 days of work. So first 2 days of work, and then there is a float available. For excavate, there is no float because that was the critical activity. And for the power line, it was also, it has only 3 weeks of work, and then remainings were the float of the activities. So this type of bar chart schedule is called as the early start schedule for the project. Early start schedule. So this early start schedule we can use it further for the resource assignment. Okay, so let's see how we can use it. And okay. Before going into the resource assignment, on the other extreme, there is a late start schedule. Okay, in the late start schedule, what we do is we start each activity as late as possible. So for example, we start drill well as late as possible. We start deliver material as late as possible. And we start power line as late as possible. So although it will not be a very convenient schedule, in this case, since we are starting each activity as late as possible, there is the flexibility in the schedule becomes less and less. So therefore, that late start schedule is not very useful for our scheduling purposes. Only the earliest start schedule is very useful for our purposes. But more practical schedules are those which are somewhere between the early start and the late start schedules. Okay.
I'm sorry, Professor. Can you please explain again what does mean float at workday? I'm a little confused.
Yes. So we started from this diagram. Okay. So this diagram is only showing the early start and late finish span for each activity. Okay. And then we modified this diagram. Did not modify this diagram. We just represented the work on each activity. So work on each activity is represented by this duration, 4 weeks. So if we assume the early start of each activity, that means we will represent the work on these early starts. Okay.
Okay.
Yeah.
What does mean float? Float.
Float is the free time. Okay. Float is the total. Float is the same as the total float, which we calculated for each activity over here, right? So whatever the work will be there, and whatever remaining in up to this latest finish, that will be the float. That will be the float. So for example, from here, from 0 to 10, only 4 weeks of work is there, then the remaining will be float. So from 0 to 5, only 2 weeks of work is there, then the remaining is the float. For excavate, from 0 to 5 weeks of work, the remaining is nothing. There is no float over here. And that's why it is also a critical activity. So in this way, we have scheduled all the activities as the early start activities. Is it clear?
Yes. Now it's more clear. Okay.
Yeah,
Thank you.
a little bit clear. Okay, so we can use this early start schedule for the resource assignment. So now I have moved to this figure 20 actually. Okay, and now you can see that instead of those over here like asterisks, okay, in the early start schedule, or these looks like these asterisks are looking like dots, I am representing with numbers. Okay. I am representing it with numbers. So these numbers represent the number of resources, workers. So suppose we are now instead, in addition to the as a part of the project planning, we have to estimate the duration of each activity to create the schedule. And in addition, we have to also calculate the number of resources needed for each activity. So therefore, there is this is the additional data over here, 4, 4, 5, 6, 2, 3, 7, 4, 5, 8. So these are the resources, additional resources. So in this case, we can have many different types of resources, human resources, materials, as well as machinery. So in this case, for simplicity, we assume that we are only looking at the human resources or the number of workers needed. So we will say that for drill well activity, each week we will need 4 workers. So 4 over here under the duration column is showing the 4 weeks, but 4 over here shows that we need 4 workers to work each week on this drill well activity. Okay, so because these are the 4 weeks of the work in this activity, so each week we will need 4 workers. So therefore, for 4 weeks and 4 workers, so total worker week we need are 16. So plus 4 is 16. Similarly, for the deliver material, we also need 4 workers. Okay, 4 workers. For similarly, on the excavation, we need 5 workers each week. On the power line, we need 6 workers each week, and similarly for other activities. Okay, so the required number of workers will be calculated or estimated separately. This is one of the input to the project schedule. So once we input these numbers over here, so we can see that in this week 1, we need 4 workers on drill well, 4 workers on deliver material, 5 workers on excavate, and 6 workers on the power line. So in total, we need 4 plus 4, 8 plus 5, 13 plus 6, 19 workers in the first week. Similarly, if we add up for all for each week, we need 19 workers in the second week, 18 workers in the third week, 12 workers in the fourth week, and so on. And then we see that we have, in this way, we have estimated the requirement for the number of workers each week, right? So now you can see that we have used this early start schedule in the form of the bar graph to calculate the requirements for the workers each week. Understand? So now if you can see that the number of requirements of the workers is fluctuating quite a lot. So for example, it starts from the 19 workers and it reduces to 18 workers, and in between, first it reduces, then it increases, and then it reduces again. So there is a fluctuation in the required profile of workers, in the requirement of the workers. So fluctuating requirement of the workers. So there is this fluctuating, okay, worker requirements. We can also say that there is this uneven worker requirements. So from the construction management point of view, this uneven worker requirements is not a good thing. The reason is that if the workers are working on this project, and then you can see that in the first 2 weeks we need 19 workers, and then in the next week we need 18 workers. So if we hire the 19 workers for the first 2 weeks, then for the next week we will have to fire 1 worker. Okay. That means we cannot pay to that 1 worker. So that means this will not be good for the morale of the workers. Okay, so for example, out of these 19 workers, 1 worker will always think that he will lose his job after 2nd week. And similarly, after 3rd week, 6 of the workers will think that, okay, they will lose their job after 3 weeks. So there will be a constant hiring and firing of the labor, which will not be good for the morale of the worker. And maybe in those situations, the company will also be very, will not be in a good positions to properly hire and fire the laborers in that time. There may be some labor union requirements as well, that you cannot, if you have to hire the worker, you have to hire for a certain period of time. You cannot fire those laborers, etc. So this is a big issue for the labor management. Okay. So in order to improve this situation, we need to reduce this fluctuation. So for example, this fluctuation is from 19 at the highest level to the 8 at the lowest level, right? So if we can reduce this type of fluctuation as much as possible, then this will be good for the project management, for the construction management. So this process is called as the resource leveling. Okay. Resource leveling. Okay, so in this resource leveling, this resource fluctuation is reduced. So for example, instead of 19 to 8, maybe there can be, we can reduce it to like 15 to 12, something like this. So that means throughout the project, we don't use more than 15 workers or not less than 12 workers. So this type of reducing or the fluctuation resource leveling can be performed by considering that we are using, like, if we can total it, and we can, if we can total it, I think this total will come out to be like 195 worker days or worker weeks. Okay, okay. Since the example is like using the days, so we can say that it is using like 195 total worker weeks or days, whatever. So if we divide this 195 by 15, so then that means that we need the average is about 13. The average is about 13. So if we can keep this average of about 13 plus or minus little bit, then it will be that this resource leveling profile will be much better in that situation. So for this purpose, therefore, in this case, for this 19 and 18, we may need to reduce it. We may need to reduce it. Okay, so how we can reduce this 19 to some other value? So maybe if we see that this power line activity uses 6 workers. So if we can delay this power line activity by, say, by 3 weeks, which is possible because that's why we have drawn this line over here. Okay, so instead of 6, we can remove this, and then we, instead of starting from like at the beginning, we started from the day 4. So 6 will be here. So 6 will be here, and then these 6 will be removed, and then the total requirement over here will be reduced by 6. So it will become 19 minus 6. That will be 13, 13, 13, 13, 13, 12. In that case. And similarly, some other activities where it is a possibility to move the activities within their float, and we can do it. Okay, so this is the use of this drawing the resource requirements on the project on the bar chart. So therefore, some of the adjustments are made, and this is the adjusted or the improved level of resources assignment. So this is the same schedule. The only thing is that some of the changes have been made in this schedule. And then you can see that after making these changes, the resource requirements 13, 13, 15, 15, 13, you can see that now the resource requirements is only changing between 15 and 13, okay, 15 and 12, okay. It's only changing between 15 and 12. So there is very less fluctuation, okay? And the resource requirements is much even. Okay, so how has it been done over here? So if you compare it with the previous schedule, so you can see that there was a change in this power line. So now I can show you the previous one. You can see that, just remember that this power line in the previous schedule was starting here, but now we have delayed it by 2 days. Okay, so by doing this, what happened was that we delayed it by 2 days, so it becomes 13. Okay, so this power line was here, now it is starting over here, and the other things were kept as it is. Okay, and similarly, the other change was in the in this assemble tank was here. Okay, I think this was not changed. Yeah, and assemble tank was also changed. Okay, so assemble tank, yeah. So you can see that the changes, some changes have been done over here, and it is very easy to see because you see that earlier all the lines. There were no empty lines over here. So the second change was done in the assemble tank.
Professor, I have a question. Can I ask?
Ask please, yes.
So, does it mean that workers which will deliver mat will then do like a power line?
Yes, so here we are assuming that the workers can do all works over here. This is our assumption.
Yeah, but in reality, I think maybe it doesn't matter how many workers in one day is working, because there are different types of works, and for example, who can do like a pumping system, he cannot do maybe a foundation. And so
yes.
is it usable in reality? What do you think?
Yes, it's also possible. Yeah, but I think because since the purpose over here is to illustrate the illustrate the calculations. In reality, you will have the different types of labors, and then you can put those types of labors into the software, and the software will be very helpful to schedule all those labors. But since for simplicity and for showing the calculations, the mechanism of the calculations, we are assuming that all workers can do all type of works in this project.
Okay, I got. Thank you.
So the second change was done in the assembled tank. Okay, so it was delayed by 3 weeks, and another change was done in the install pipe. Okay, install pipe was also changed by 2 weeks, and install pump was changed by 1, 2, 3, 4, 5, 6 weeks. Okay, so some of the activities were started late, and then by doing these changes, so we have reduced this fluctuation. So now we can see that 13, 13, 15, 15. So these changes have been done. But now you can ask that how these changes were done. Actually, this was the trial and error. Okay, this is the trial and error. Although there are some algorithms for making these changes, but due to the limitation of the time into this schedule, into this course, we are not going into those algorithms which can help us decide which activities will be moved. So one of the algorithm is that we move only those activities which have the highest amount of slack available. But this is just a rule of thumb. Sometimes it may not work out very well. So by the trial and error, you move certain activities, okay, within their float. And also you have to keep the logic of the network. So for example, if I see that if you move power line over here, and then let me go back to this figure, because the bar charts do not show the logical relationship between the activities. If we have to be considered, you have to also be very careful that if we move the power line, will it affect the other activity or not? So if, for example, if I am moving power line by 2 days, so it will be finishing at 5, and its following activity is install pump, which is starting at say 10 over here. So in this case, it is not going to affect it. Okay, but we have to after each change, you have to look at the diagram as well, whether other activities are affected by this or not. So therefore, if making a change in the power line is also affecting the install pump line, so you also have to update the install pump as well. Okay. So as of now, these changes have been done by the trial and error, and then as a result we have obtained this profile 13, 15, 15, and which is quite uniform, and the resources are more or less uniform as well. So in this way we have leveled the resources. And then in this case, now this given these requirements of the resources for each activities, this resource profile looks quite fine, and the project schedule is seems to be doing quite well in this situation. So in this case, we have seen that originally the duration of the project was 15 weeks, but after doing this resource profile, there was no change in the duration of the project as well, which is also good in this case. However, this situation may not always be possible, because since we are delaying some of the activities, and sometimes we have to delay some activities more than the available float in those activities. If we have to delay some of the activities more than the available floats, then it is most likely that the duration of the project will also increase. Okay, so that is called as the resource limited scheduling. Okay, that can be the situation. For example, in those situations, for example, we can say that we have the labor shortage. Okay, so if we have some labor shortage in certain periods of time, say for example at the end of 6th week, in the 6th week to 10th week, we don't have more than 10 laborers available. So in those situations, if we don't have more than 10 laborers available, so certain activities will have to be delayed, and it may likely happen that some of the activities will have to be delayed more than their total float available, and then that will ultimately delay the project. So the resource leveling can be within the available float, and it can also be outside of the total float. So if it is outside of the total float, then the duration of the project will also be delayed. All right. So that was the resource leveling. Any questions? Okay. Next is the one of the topic which is called as the. I will skip these text-based slides. Okay, now it's about 10 minutes, no, just 5 minutes left. So maybe I can keep that topic for the next class on Thursday. So there are some practical considerations in the network use, and then I think you can use it. Okay, okay. Next is, okay, so I want to ask, have you accessed the Microsoft project?
No.
Yeah, so I have shared, but I have already shared the information about the Microsoft project, how to access it on the university's computer. I think you may have already done this type of access by the virtual lab, because you have been in this virtual lab situation for quite a lot of time. So you know how to access the software on the labs. Not only Microsoft project, but other software on the computer labs. You can access it. Okay, so for the scheduling repetitive projects, there is this technique which is called as the linear scheduling method. Okay, so the linear scheduling method is a very useful technique for the highway projects, and also for some for building projects as well sometimes. For example, especially for the structural part of the building. So for example, when there is a multi-story building, so many of those structural components like formwork, concreting, reinforcement, these will be repeating in every floor. So for those part of the work in the building projects, linear scheduling method can be used. And for highway projects, this linear scheduling method can also be used. So in the linear scheduling method, basically you create these kind of diagrams. Okay, and these diagrams show the progress on each of those repetitive projects in a more convenient way, which is normally not very easy to represent on the network diagram. So linear scheduling method diagram is an alternative to the network diagramming when there are some repetitive activities on the project. So in this case, as this diagram shows that this clear and strip activity starts from somewhere between week 0 and then finishes at by the end of say week 2, and then this drainage activity takes place from week 1 to somewhere between week 2. And on the vertical axis, you can represent the location along the project. So if there are total of 50 stations on this highway project, so starting from station, the progress can be shown by the station numbers 10, 20, 30, 40, etc. And on the horizontal axis, you can represent the time. So there are, in this project, there are 1, 2, 3, 6 activities, which have a lag between those activities, but this lag can be also shown in these activities, and their overall progress in a linear manner can be also shown in those activities. So this linear scheduling diagram is also very useful for these kinds of projects. So that's all for today. Do you have any questions?
Yes, Professor. I cannot find the. Where did you share the link to Microsoft project